All right, good afternoon, guys, or morning, or whatever time you're watching this. We're going to start on Activity 6 of the Unit 2 review. It has the Green Lantern symbol, which is very special because that's my husband's favorite superhero, so yay. Okay, so we're going to start on the guided practice. Activity 6 is all about key features of graphs. And so it's about what these different points on a graph or the different pieces of the graph represent. The good thing about Activity 6 is we're pretty much got the same questions for each graph, which is kind of easy, and it's just interpreting, okay, well, what's happening in this graph? Well, what does this point mean? So, all right, so let's just get started. All right, so number one, we have this graph, and it's measuring bath water depth. So this is like imagining a bathtub that you're filling up with water, and then eventually you'll let the water out. So that's what this is measuring. All right, so question A, does this graph represent a function, and how can you tell? So let's look at it. The first thing we want to do is ask, does it pass the vertical line test? So if I were to take a vertical line, which I'll use my pen, will it touch more than one point at any given line? And it should not. It should only touch 1 point per vertical line. So yes, this is a function. You can say it passes the vertical line test. Ooh, you cannot see that. There we go. Okay, it is a function because it passes the vertical line test. B, what is the y-intercept of the graph and what does it represent? So the y-intercept is where your function crosses or touches or intersects the y-axis. So that would be at this point, which is 0, 0. And then it asks, what does it represent? So we're going to look at both the x and y axis. My x coordinate is 0, so 0 minutes since the bath began. And my y is 0, so the depth of the bath water is 0. So when we started the bath, there was no water already in the tub. So we can say we started our bath in an empty tub. And there's a bunch of different ways you can say this, and that's okay. You don't have to say it the same way every single time. All right, C, what is the independent variable? And D is what is the dependent variable? So this is where you're asking which variable depends on the other. So does how long the bath lasts depend on how much water's in the tub? Or does how much water there is in the tub depend on how long the bath lasts? Which both of those kind of sound funky. But since you started the bath, you're filling it up. Once you filled it up, you're like sitting in the tub and then you drain it. And none of that affects the time. Now, your time kind of affects how much water's in the bath, though. Also, your x-axis is always independent. Your y-axis is always dependent. So the independent variable is time, or the minutes since the bath began. I don't know if I said that right. The dependent variable is is inches, so we can use the unit, or the depth of the water. Okay, so time and inches, the depth of the water and the bath time. Okay. All right. E. Okay, here. Oops. Sorry. There we go. E. What is the domain and what does it mean? So the domain and range. Again, domain is every possible x-axis. Let me see if I can get the graph in here too. Okay, there we go. Is every possible x value, and the range is every possible y value. So if we talk about the domain, we're measuring time. We're measuring how long, the minutes since the bath began. So we're not going to have negative minutes. That doesn't make any sense. We're also, after 12 minutes, we have an empty tub. Our bath is over. We're not going to keep measuring after our bath. I mean, time is going to go on. Time's not going to end, but we also don't have any more data after that point. So our lowest X value is 0. Our highest X value is 12. So our domain are the values of X between 0 and 12. And what does that mean? Our bath lasted 12 minutes. And what else could we say? Yeah, we can just say our bath lasted 12 minutes. We have data for every point from 0 to 12 minutes. Okay, the range. The lowest amount of water in our bathtub is 0. We're not going to have negative values because I don't know how you could have, like, okay, if you're talking about how full your bathtub is, 0 is as low as you can go. You can't, like, have negative water. I don't even know how you could even, like, make an excuse for that. So, the depth can't be negative. And then the highest amount of water we have is 8 inches. After 8, we didn't fill it up past 8 inches. So, what is the range and what does it mean? Our range are the Y values between 0 and 8. And at any given time, the depth was between 0 and 8 inches. So at any given time, your depth is going to, how much water's in the tub is going to be anywhere between 0 inches and 8 inches. 8's the maximum, 0 would be the minimum. Look, those were the next questions. Okay, so identify a relative maximum of this graph. And then, actually, let's go with H first, where it says identify the absolute maximum. So the absolute maximum is the absolute highest point on this graph. And the absolute highest point on this graph, the absolute most water we have in here is 8 inches. So that's our absolute maximum, is 8 inches. And, okay, and it says interpret its meaning in the context of the situation. The most water we have in the tub is a depth of 8 inches. Okay, so then a relative maximum. A relative maximum is any maximum. It doesn't have to be the highest point, but it's any maximum on this graph. So a maximum, I had to go look up the absolute best definition. A maximum is a point where we change from increasing to decreasing. So the point where we change going from increasing to decreasing is a maximum. Here, the only time we change from increasing to decreasing is at 8. Now we don't have like one point. This whole line would kind of be a maximum. So the only time we go from increasing to decreasing is at the height of 8. So it stays at 8 for a while and then decreases. So the only maximum we have at all is 8. And we'll put inches just so we keep our units. Okay, minimums, that would be the lower points. So what is the absolute lowest point on this graph? And that would be at 0. 0 inches. And that's the least amount of water we have in the tub. Okay. All right, so let's go back to I, which is a relative minimum. So again, kind of like how we had our maximum is when we're going from increasing to decreasing. Our minimum is when we're going from, go this way, decreasing to increasing. So if we look over here, anywhere we go from decreasing to increasing. So there is nowhere where I'm actually going from decreasing back to increasing. So there is no other relative minimum. The only minimums we have are 0. Something about a relative minimum, though. A relative minimum or a relative maximum, if it's relative, it can't be an endpoint. So 8 inches was okay because it's not an endpoint. Like our maximum was okay because we did go from increasing to decreasing. But we don't do that for a minimum. If this were upside down maybe, but we don't do that. We do have 2 minimums at 0, but it can't be a relative minimum because those are endpoints. So here we do not have a relative minimum. So we're just going to write none. You can write NA. Sorry, I'm off the edge of my desk, so that is some really crappy handwriting. I'm sorry. Yeah, I'm not really sorry. I'm working hard on these videos, so... Okay. Alright, so let's start on number 2. Let me try to rearrange the desk a little bit so that we can get... I'm in a lot smaller space than I'm used to working in. Like my desk at work is has a lot more room. My desk at home has a lot of craft stuff on it and a lot of kid stuff, so I'm just doing the best I can. So yeah. Okay, number 2 is the exact same questions but for this graph. Alright, so A, does this graph represent a function and how can you tell? So if I look, every single x value has only one y value. It would pass the vertical line test, so yes, it is a function because it passes the vertical line test. I'm just going to abbreviate. Alright, what is the y-intercept of the graph and what does it represent? So here's my y-intercept. So if I look at my units or at my labels, this is the number of years since 2010. This is my stock worth, but it's in hundreds of dollars. So my y-intercept, normally I would say, oh, it's 0 too, but this is in hundreds of dollars. And since we're having to interpret the meaning of this graph, we're going to say 0 to 100. So what does it represent? So 0 years since 2010, that would be the year 2010. So in 2010, the stock was worth $200. Okay, what's the independent variable? So is that how, all right, so this is an easy one. Time passing. Is time passing going to depend on how much your stock is worth? No, time marches on. It does its own thing. It's independent. And how much your stock is worth is going to depend on the year, whether it was a good year or a bad year. So our our independent variable is years since 2010. Our dependent variable is the stock price or the stock worth. So if I'm looking at, if I want to know how much my stock was worth, it's like, well, what year was it? Was it this year because this year was a great year, or was it this other year because this year was terrible? So how much it was worth at any given time depends on what year I'm looking at. Okay. I keep trying to scoop my page up for the questions, but you still need to see the graph. So, okay, what is the domain and what does it mean? So we are looking at years since 2010. So years since 2010, we started at 0 years since 2010, and we have all the way to 10 years since 2010. So we can think of this as one of two ways. This is one of those that if you give me a good argument, now I can't speak for every teacher. If you gave me a good argument, I could give you credit on this. So we could say that the years since 2010, we could go from 0 years all the way up to 10 years. It's 2020. We haven't had more than 10 years. Or Now, with coronavirus, like, you could argue that we're not going to have any years after 2010. That's really morbid, though, so we're not going to do that. We could argue that next year's going to come, and the year after that's going to come. We're not going to have any year. I mean, we're going to keep having years after 2010. Time's going to keep moving on. So what we could say is that x is just greater than or equal to 0, because time's still going to move on. I think my other argument, though, is that this doesn't have an arrow at the end, so I think this is more appropriate, because this is all we have data for, is from 0 to 10 years. But if you argued this with me, I would be okay. Like, I don't know that I would take off for that, because, I mean, if you gave me a good argument, I could see that. That's just personal for me. I think I'm going to use this one just because we don't have any data past 10, so I think we'll just use this. But I think you could argue either way. Okay, so what is the domain? We'll say from 0 to 10, and it means, it's the time since year 2010. And again, we only have 10 years. So, I mean, that's kind of a good one to argue, though. All right, our range. Again, we could, it's stock price. So you could argue that your range can be all real numbers, because we could increase our stock price. There's no cap on that. Or it could decrease down so much. I don't think you could go past 0. I don't know enough about stocks to know if you could have a negative stock price. I don't think it works that way. But I don't know enough about stocks. That's why I pay someone to handle mine. So we'll do kind of like this. We'll just use the data we have. And my range, let's see, my lowest y point on this graph is 0. All right, wait, y such that 0 is less than or equal to y. And my highest point is at 7. Now, if you remember, this is in hundreds of dollars. So that would mean my worth would be $700, not $7. So this is my stock price in the given time frame. Again, I think you could make an argument, because we don't know how much it can equal. I mean, it could increase or decrease in value, but let's just go off the data we have. Okay. All right, so a relative maximum of the graph. So remember, a relative maximum is anywhere where it goes from increasing to decreasing. And there's actually quite a few relative maximums. So anywhere it goes from increasing to decreasing. So here, here, and here, all three of these points would be a relative maximum. You can list any or all of them. So we have a relative maximum at 4, let's see, at 6, and at 7. And actually, remember, this is in hundreds. So at 400, at 600, and at 700. So any of those would be a relative maximum. Just pick one. I maybe would not pick 700. I would pick maybe one of the other two, just so that you have something different, because 700 is our absolute maximum. So that's 700, and it's going to be in dollars, right? Because it's our stock worth. This is the most the stock has ever been worth. Okay. All right, let's go to relative minimums. So our relative minimums are anywhere where it goes from decreasing to increasing. So let me do it in a different color. So here, here, and here would all be a relative minimum. Those are all endpoints. And now this one's not going from decreasing to increasing, but it is leveling off. So I would still say that that would be a minimum. Okay. So, relative minimum, we have a minimum at 0, at 200, and at 500. Okay, the absolute minimum, the absolute lowest the stock was worth would be here at $0. That was the least the stock has ever been worth. Okay. All right. So here we go. So we have interpreted that graph. We've looked at every single key feature and made some judgment calls on that. Let me go on to page 3. All right, so page 3. So we've got just some graphs. We're going to just quickly go through, name domain, range, minimum, maximums, and relative minimums, maximums. All right, so remember, domain measures all possible x values. So we're going to go from the least x to the greatest x. So this x, the lowest x value on this graph is negative 1, 2, 3, 4, 5. And the greatest x value on this graph is 0, which feels wrong, doesn't it? It feels like 0 should always be your least, but this is on the negative side of the x-axis, so my domain's from negative 5 to 0. Okay, my range goes from the lowest y to the highest y. So my range is from, let's see, negative 1, 2, 3, 4, 5, 6. All the way up to negative 1, 2. Okay, let's go ahead and do domain and range for all of these. We'll talk about domain and range, then we'll do minimums and maximums, and then we'll do relatives. Okay, so my domain for B is, so this is a discrete graph. It's just a bunch of points. So since it's a discrete graph and all I have are just a limited number of points, I'm just going to list every x value that has a coordinate. So this is going to be a list. So we're going to start with I like to go from left to right. I just think it's easier. So we're going to go, this is negative 1, 2, 3. We have values at negative 3, at negative 2, at negative 1. I don't see any at 0, but I do see 2 at positive 1. Okay, and so those are all the x values that have a coordinate. We're going to do the same for the range. So I like to start, again, I like going from lowest. I like my numbers to be in order. So I'm going to start from the lowest points and go up to the highest points. So we have coordinates here at negative 2. We have this coordinate at negative 1. I don't see anything at 0 or at 1. I do have a coordinate at 2. I have a coordinate at 3. And I have a coordinate at 4. Okay, so here we use inequalities because this is continuous data. It doesn't break up. Here, these are discrete points. That looks kind of cool. These are discrete points, so they're going to be in a list. And then when we get here, again, this is continuous data, but if you were to keep going, if you were to zoom out, this is going to keep going to the right and to the left. It's not going to stop. It's going to go from negative infinity to positive infinity. So I don't know if you remember from the last video. But here our x is going to be, or our domain is going to be all real numbers. Okay. Our range, same thing. It's going to keep going down as you zoom out. And it's going to keep going up as you zoom out. So again, my range is going to be all real numbers. All right, so let's go on to minimums and maximums. All right, so first we're just going to go over absolute minimums and maximums. So the absolute highest point on this graph is -2. The absolute lowest point on this graph is -6. And I want you to notice in your range, your range goes from -6 to -2. Well, your minimum is -6 and your maximum is -2. There is a relationship between your minimums and maximums in your range. And I have a lot of students that struggle with minimums, or not minimums, that got minimums and maximums down but struggle with range. There's a relationship between those. So just kind of keep an eye out for that. Okay. All right, so for B, my absolute highest point is going to be at +4. My absolute lowest points are at -2. Again, this is why I like listing them in order. -2 is my minimum, 4 is my maximum. Okay, and then when we go to this graph, now this one keeps going on forever in either direction. So since it's going to keep moving forward, there is no cutoff. There's no, hey, this is the highest point you're going to hit, or hey, this is the lowest point you're going to hit, because this goes on forever. So there is no maximum and there is no minimum. Okay, so my relative minimums and maximums. So again, this is where we're going from increasing to decreasing. I'm sorry. Yes, maximums go when we're changing from increasing to decreasing. So the only time I change from increasing to decreasing would be right here at -2. So in this instance, our absolute maximum and the only relative maximum we have would be at these 2 points. Or, I mean, they're going to be the same. And with our minimum, the only time we go from decreasing to increasing is at -6. So, so yeah. So our relatives and our our relative minimax are the exact same thing as our absolute minimax. All right, then we go to this section, or to graph B. Now, these are just discrete points. You're not going from increasing to decreasing or from decreasing to increasing. So there's really no relative minimum or relative maximum here. You're not going from, you're not changing direction. They're just points. So it's kind of hard to say, oh yeah, I'm going from increasing to decreasing, especially since this isn't a function and we have 2 points at the or 2 things at the same point. It's kind of hard to tell. So, okay. And then let's move on to C. So C, we have this continuous line. Again, there's no absolute minimum or maximum. And we don't change from increasing to decreasing or decreasing to increasing. We are increasing the entire time as we go from left to right. So, no relative maximum, no relative minimum. All right. So last piece of the guided practice is number 4. Okay, a fundraising organization will donate $250 plus half of the money it raises from a charity event. So it's asking all these questions. I was going to say let's start with E first, but I think let's talk about independent and dependent variable. Skip C and D and go all the way to E. Okay, so what is the independent variable and what is the dependent variable? So the 2 things we're measuring, the 2 things we don't know is how much money it raises from the charity event. So we don't know the money raised. And that money raised, we're going to take half of it and donate it to something. So we don't know how much we're going to donate. All right, so how much we donate is going to depend on how much we raise. How much we raise doesn't depend on the donation because we can't make the donation until we've raised the money. So my independent variable is the amount of money raised. And the dependent variable is the amount of money donated. So we're going to use these two things to make our variables. So let's use R for money raised and D for donation. We're going to skip ahead to E and write our function rule. So remember, this is a function rule, so we want to use function notation. So we're going to do D of R. And what that tells me is that the donation in terms of the money raised. So again, this is another way of showing me that my input is how much I'm raising and my output is going to be the donation. So D of R is equal to, so let's talk about this part for a minute. How do I know how much money they're going to raise? I mean, not raise. How do I know how much money they're going to donate? Well, they've already committed to donating $250. On top of that, if they raise money, they're going to take half of what they raise and donate it. So half of the money raised. So D of R is equal to $250 plus half of what they raise. All right, so let's talk about the domain. The domain is how much money is raised. So what is the lowest amount of money that this fundraiser could raise? It's not going to lose money. Hopefully it's not going to. And even if they do lose money, they're not going to dock it from the donation. So the lowest amount that we could say they raise is $0. Well, let me not write that down yet. The lowest amount they can raise is $0. Now, the most they could raise, there's no limit. They could raise $5. They could raise $1 million. They could raise $100 million. We don't know. We don't know the extent of this charity. We don't know what they're going to do. So we're not going to put a limit on them. So my domain is just that x is greater than or equal to 0. They're not going to raise negative dollars. And we don't know how much they're going to raise. There's no limit to the amount they could raise. And that's represented by the fact that we don't have like x is between 0 and some other number. All right. So let's talk about the reasonable range. Okay, so the range is measuring their donation. Well, they've already committed to donating $250. So the lowest amount of their donation is going to be $250. But again, we don't know how much money they're going to raise. So there's no limit to how much money they're going to donate. So my range is going to be that y is greater than or equal to 250 because they've already committed to donating $250. And again, there's no limit to how much they can donate. Well, there is. It's based off of what they earned. But since there's no limit to what they've earned, the limit's half of what they earned. So, but there's nowhere for us to measure that. We're going to say there's no limit on the donation. Alright, so that is, I believe, the entire guided practice for Activity 6. Thank you so much for your attention. I hope this was a helpful video. I hope that you're remembering some of the stuff from Unit 2. I know it's been a while. Well, it's been a while for some of us. For the people who are in semester-long algebra, it hadn't been that long. But the people who are in year-long algebra, this is from like October. So anyway, I hope this is helpful. I hope it's a good review. And feel free to email me or your teacher any questions you might have. I will have another video soon. Hope you guys have a great day.